Okay. Okay, here we are. It's going. Just waiting for some people to join here. Let's see if somebody is joining. Hi, Nick. Hi, great to see you. Yeah, it's been some time. Yeah. Just let me just check the stuff here. I'm on a new setup, by the way, so I just need to give this a quick look here. Seems like everything. How's the sound? Is the sound good? I have the feeling the camera quality, something is wrong with the camera. Need to figure that out later. Okay, yeah. So I'm back. Actually, I wanted to do this last week, but yeah, there were some things to take care of. Okay, so let me just try to figure this out here. Today we're going to start and look at Spotify's or data engineering at Spotify. And in the last stream we have looked about into the engineering culture at Spotify. Something super interesting. For everybody new to this video, check out the old one. Yeah, I found this. I found the whole culture at Spotify, the data-driven culture, very interesting. And so, what are they actually doing, and how did they evolve the whole platform? And one thing that is interesting is I have found some pages on the Spotify Labs. Let's call it blog. I'm not sure if it's a it's a blog, and they have posted their journey from 2016, how they evolved their platform from a Hadoop and Kafka based platform into a platform for based on Google Cloud platform. So they moved from a local installation or a local data center to an online platform, to a cloud platform. No, I need to. Okay. Yeah. So it's a three-part blog series. Let's just quickly, what are they doing? I can actually, let me show this. When you are in your Spotify, then you have the option to, this is my Spotify. You have Discover Weekly. And Discover Weekly, this is a playlist that is specifically, for instance, basically made for me, or made for you, and that is based on your listening habits and so on. And they are doing multiple of those, so they are creating mixtapes and so on for you based on your listening habits. And how are they doing it? Nick is going to like this. This is more or less again clickstream processing. So you're they are every time you start a song, every time you press pause or do something on the interface and look something up, this is then logged, and Spotify is analyzing this, and they are putting it into good use for these discover features. Nick says Twitter has moved all their data 300 petabytes from local Hadoop cluster to Google Cloud Platform. Also seems to be it's popular now. I'm not sure. I'm not sure. I need to get more into the differences between those cloud platforms and why people are using a Google Cloud Platform and not Amazon or Azure. I need to get a bit more into that. Yeah, Clickstream. It's interesting. It's more or less everything is Clickstream, and this is because what you want to do every time is you want to analyze what are users doing, and so you can bring new services, or you can optimize your service or your offer to the customer. So a lot of stuff is Clickstream, and the thing is, we can quickly go over this here. It's for Discover Weekly, and they're doing a lot of A/B testing, and so they need data for the A/B testing. And yeah, so let's just quickly look at the setup. What they had a few data centers across the globe, and those are more or less the ones on the left. And then they had a central Hadoop data center where they stored all the data, and then they could do ETL jobs and they could analyze the data. And the idea was in HDFS, the logs that you create from the service, these logs are posted into Kafka, and you're creating in the end 1 hour buckets in HDFS. So when you analyze, you can exist, but anyway, cloud over on premise. Not necessarily. I need to do a video series about on premise versus cloud, and I have sketched this already, or maybe we do this in the next stream. So basically the one problem they had here is you have this central HDFS instance, and when this instance goes down, then the whole thing stalls, and you cannot process the data. Yeah, they are storing the files in Afro. This is a row-oriented file format. There is a interesting, as always, I'm going to put the links to all the sites in the description and in my cookbook. Datanami has a quick overview of the differences between ORC files, Parquet, and Afro. And basically, a key difference between those is that Afro is a row-oriented file format, and Parquet or ORC, which are mostly the same. As I have learned, Parquet is more Cloudera based, and ORC or org that is more Hortonworks based. This is not so mega different. But the key difference here is that those files, Avro files, are row oriented. So so you don't have columns, and it's very optimized for writing, for quick writes and putting data in. Exactly. Yeah. And yeah, so they have a delivery system from the on-sites, from the data centers, which are 2 or 3. How many were there? I think there were 2. Just data. Multiple data centers. Okay, multiple data centers on 2 continents. So they have multiple. They have a X amount of data centers, but on 2 continents, of course. So the interesting thing here is they have the Afro files, and those are getting into HDFS, partitioned based on hourly buckets, as I said. And one interesting thing here was that this is a relic from the past, when the first event delivery system was based on the SCP, secure copy command, and copied hourly based syslog files from all the servers to Hadoop. So they didn't even use Kafka brokers. They, on this side in the data center, they just got in and made a secure copy directly into HDFS from a cron job or something. So very interesting, and a very simple solution. In this solution, I find interesting here is that these log files are put into Kafka brokers. They have a grouper, Kafka grouper system here, where they said in this article, this is something they have written themselves. So they get the data that is coming in and grouping it into a single topic, and this topic is then can be read by the syslog consumer, and from there put into HDFS. Interesting thing here is usually what you do is the acknowledges that something is written or is delivered well, or is delivered. How do you say this? Sorry, I'm still a bit sick as well. Is delivered correctly. This is from another Kafka broker. So this is from the Kafka brokers in the main data center. They send the acknowledge back to the syslog producer. Usually, this thing here sends the acknowledges back. So this is a interesting solution here. And then data is getting into. Let me just check something. Data is getting into HDFS, and what they also run is a liveliness monitor because of their problems with HDFS, to basically make sure if HDFS is still up. Because when HDFS is going down, then those things, those brokers or these brokers and consumers, they need more or less the brokers, they need a lot of storage, because if you don't have enough storage, the topics or basically the Kafka topic is running out of memory, and you cannot store any more data from the syslog producers, so everything stalls. So in this way, when you have the brokers with a good size of storage, then HDFS can go down, and you're buffering the data, and then when HDFS is coming back, you are going to push the data back into HDFS. So they said the problem was they are running. Let me just find it here. They were pushing more than 700,000 events per second. So more than 700,000 click events every second. And it was working good, but they have seen that they're getting more and more problems with the HDFS instance and with cluster reliability. One thing is this is not a crucial part of the platform, as you can see. So if this thing goes down, then the logging doesn't work, or Discover Weekly doesn't create a new playlist or the discovery playlists are not getting greeted in this hour, which is, and the old ones keep staying up another hour. The problem, however, is when the HDFS instance is down, or when the whole system doesn't really work, you cannot really use the ETL jobs or the analytics jobs, and you cannot really find out what is happening with the system. And all your development work, where you're refining the system, where you're doing A/B tests, and you want to find out how the A/B tests are working, then you're in trouble. You want to have a reliable system, and when this system goes down often, it's more than annoying. Yeah, they have seen that more or less the whole thing was exploding. So they had a very nice graph of growth. 2015, okay, but yeah. So this is a older thing. This is from February 25th, 2016. Yeah. Guys, if you have any questions on that, we can just quickly write it in the chat. I'm scrolling over it so I don't forget stuff I wanted to mention, and then we are moving to the second article in this 3-part series that they have written. Yeah, one thing also interesting. These jobs add around 30 minutes of latency. Okay. So they have found this is not the optimal platform to go for, and so let's get into part 2. Part 2, that is, they made the decision to. Well, let me just start from the beginning. They made the decision to move away from this whole structure that we have seen before into something like a reliable, persistent queue that is writing into HDFS. And this is a high-level system design. Yeah. So they have the service using APIs directly. So basically the app that is running on the system, the app is using APIs, and those APIs are directly sending into a event delivery service, and are using a file trailer. I'm thinking these are the hourly data files, and this data is then getting directly into a persistent queue, and from there on it's written into HDFS. So what they were looking for is going away from this complex structure here with Kafka brokers, Kafka groupers, some syslog consumers, and so on and so on. And yeah, so they have been looking into a few things. They have been looking into Kafka. This is let's say a more traditional approach. It's more what we have seen before. It's very straightforward. It is service APIs sends data to this delivery service that puts it into a Kafka broker, and then into what was the Kafka mirror maker? I need to check this quickly then. And then back into Kafka brokers, and then with a system into HDFS. What was the mirror maker? just check. Kafka. Kafka Mirror Maker. Okay, makes it maintain a replica of an existing Kafka cluster. Yeah. Okay, that it's more it's more or less what it says. Mirror. So they have Spotify local Spotify data centers, and they are mirroring the data from those data centers into a central location with HDFS. Yeah, they said sadly, as soon as this system started handling production traffic, it started to fall apart. Only component proved stable was the KMOS. Okay. So the problem is with the mirror maker. Yeah, they had problems with Kafka producer. I mean, they're running quite a setup and quite a lot of data through it. Yeah. So they had problems with this initial thing, or with the standard Kafka setup, and so what they decided is to look into Google Cloud Platform with the PubSub service, and yeah, it can retain data and deliver data for 7 days, which is quite good. So, guys, is there a problem with the stream? I'm just wondering if I am looking at the analytics here. It looks like people are dropping out and dropping back in. Is this the case, or is everything still good? I'm not sure. It says error 0. Okay. Yeah, so they basically they have done something super simple. Where is it? They have moved to more or less these event delivery service, and this one is okay. Thanks, Nick. Strange. This thing is then putting into a cloud PubSub, and from there with a data flow job, and they're putting it into the Google Cloud Storage, and they are then putting it back into HDFS, which I'm guessing is what they're doing is they're doing it this way. So they are keeping the Hadoop data center because they already have thanks. Yeah, it's working fine. Okay, thanks. They have still this central data center because they have all their processes, their ETL jobs. They are still working, or at this point they were still working on HDFS. And yeah, when the processes within a company are established, it's not that easy to move completely to something new in one step. So you need to do this incrementally. Just so they did a load test. Currently, our production load peaks around 700,000 events per second. To account for future growth, possibility disaster recovery scenarios, we settled on a test load of 2 million events per second, which is nice. That's good. That's a lot. To make it extra hard for PubSub, we want to publish this amount of traffic from a single data center so that all the requests were hitting the PubSub machines in the same zone. Yeah, so they were really, they didn't look into the real world scenario where the 2 million events were getting in from multiple data centers. So they were really bombing it from one data center to to one zone in the Google Cloud Platform, where there then the parallel processing also gets hit quite hard because they can't do load balancing over zones. We made the assumption that Google plans zones as independent failure domains and that each zone can handle equal amounts of traffic. In theory, if we're able to push 2 million messages to a single zone, we should be able to push number of zones times 2 million messages across all zones. Yeah. So if this works with one zone, you can assume that it works, that it scales. Very good. Yeah, very easy to write for REST APIs and so on. Requests per site. Here's some statistics. So they have ramped it up, and then they stayed at 2 million requests, and then the failure, they had a few failure here, but more or less nothing. Incoming, outgoing network traffic. Can I do this quicker? 2 gigabits, 1 gigabit. And messages published. What was that here? Okay, we published 2 million messages without any service degradation received. Yeah. Okay, these are the same statistics once again. Just within the Google Cloud monitoring system here. Okay. Then they have measured end-to-end latency, which is also interesting. Yeah. On average, around 800,000 messages per second. And where is the result for that? The median end-to-end latency we measured during the test period, including backlog recovery, was around 20 seconds. So I'm guessing 20 seconds, 20 end-to-end. This would mean end-to-end. I'm guessing end-to-end here is from the event service into PubSub and then forward to HDFS, but I'm not 100% sure. In our test, we created a subscription. Then 1 hour later, we started to consume data. We consumed data in batch of 1,000 messages. The consumption could have only consumed events at slightly higher rate. It took about 8 hours to catch up. Yeah, okay. Okay, I'm not sure. They have only tested it looks like they have only tested the PubSub and basically the end-to-end latency for those 1,000 messages are, as I see it here, are 20 seconds. So 1,000 come in, and then until you have read all the 1,000 messages back with this high frequency of 800,000 messages a second, then you have a 20-second latency, which is basically nothing. Yeah, they are. Yeah, Nick says it very good. So they are using Google Cloud Platform as a reliable and robust message bus instead of Kafka on premise. Exactly, and HDFS is still on premise. Yeah, this is how I'm guessing this is, or I would say this is exactly how it is. The thing is, I'm not sure. You can never be sure why they are still keeping the Hadoop service on premise. It can be that they have some other data on it that they want to keep secure and don't want to share or put on the cloud. Or another thing is, of course, the accessibility. So if you're near the data center, or if you have a super good connection to the data center, then it's quicker than over the internet. But this is, I mean, they do everything they can. They get the data and they store the data as well into Google Cloud Storage that is coming in. So they have the data in two separate places. So if they want, they can shut down the HDFS. Next step: after events are safely persisted in PubSub, it's time to export them to HDFS to fully leverage the Google Cloud offering. We decided to give a chance to Dataflow. This is the next blog post, Dataflow. Yeah, this one I'm not 100% sure. I have looked into it. The problem is I'm not the expert with Dataflow. So, yeah, it looks not that complicated. I'm not sure if you can really set it up this simple, that you say, okay, I'm consuming, I'm sharding it into basically multiple. How would you say this? For me, this is a parallelization process here. To distribute load equally across all available workers, Dataflow is sharded before it reaches the transform that assigns window to each event. Exactly. So let me just okay. So these are the hourly windows that you have. They are still keeping the hourly windows, and those are then published to Google Cloud and written to HDFS. We have one mapping between event types and cloud PubSub topics. Single HL jobs consumes a single event type. Okay. They have already also code here. Yeah, so it's a bit more complicated than the first few here, but yeah, this is something. If you're into this, if you're into Google Cloud Platform and Dataflow, this is a nice use case for that, that you can check out. They have some other interesting topics here. This is not so much managing machines at Spotify. This is a older thing. How they are reliable export of cloud PubSub streams to cloud storage. How they are doing this, and that they are using buckets And yeah, as I said, I would need to go get into this myself more because I'm not the Google Cloud expert. But here are some interesting information. Looks very nice. Around that, maybe afterwards I can look into this and get some more insight into this. I haven't figured this out myself as well. Autoscaling. Puppet. One interesting thing is Puppet. They are managing a lot of systems or a lot of tools with Puppet. I guess you have Puppet managed daemons, and this is more or less a configuration tool as I understand it. Oops. Can we click here on Puppet? What happens when we click here on Puppet? Oh, okay. Okay. Nick says maybe they're doing full backup of all the data, Google Cloud Platform and HDFS. Yeah. That is it. If they have the money, this is a viable solution. Yeah, maybe also they don't want to commit 100 or fully to Google Cloud Platform or something else. Yeah, but they are keeping the data into platforms. Yeah. Okay. That's more or less what I have prepared for today. You can check out the labs.spotify.com blog. They have a lot more written there. This is what was the newest one? Next. So these are a few older ones. Some challenges, visualization stuff, and some stories or interviews with people working at Spotify. I have quickly looked into one. This is for me is more marketing than actual value. Yeah. Okay. Is Puppet a good tool? I haven't used Puppet. I know people who are using Puppet to, for instance, roll out clusters and pre-configure stuff. I haven't heard any bad things about Puppet so far, but I'm not the expert at with Puppet. Yeah. Okay. Yeah, I'm currently also what I'm currently doing is I'm currently thinking or working on the cookbook any further. I'm putting in more of start putting in all the links that we have discussed in the previous case studies, and I have in the let me just bring it up here. In the past, I have or I wanted to write a lot about the basics and more, or I wanted to make it like every section here is more like an article, and I realized that I don't have the capacity to write articles about everything here. So what I'm starting to do is I'm going to add to everything basically links to resources where people can find interest or find a starting point of this, and so you can easily get into new stuff. This just want to plug quickly my Patreon here. This cookbook is on my Patreon, so if you subscribe, you have the ability to download the current version of the cookbook. I'm going to upload maybe end of this week the next version of the cookbook. I'm not 100% sure. I need to check, but I'm thinking that you can. If you're not 100% sure, you can access the cookbook, or you can become a patron. And because I'm not taking the money right when you are becoming a patron, but end of the month, if you really don't like the cookbook and you think this is not worth $5, you can just quit your subscription before the end of the month, and so you don't get billed anything. So there is no upfront payment. Of course, this can be abused, but I'm thinking this is for if you're really not happy with what you're seeing, you don't need to pay the $5, and but if you like, you can keep it up and have all the updates. Okay, then Nick, something interesting next week, not next week, on Wednesday, that we want to look into. I'm having new additional case studies. We could look into something different, something like Uber or Upwork. Do I have already links for Upwork? One link, okay. Uber, okay. Yeah, okay. We're going to figure something out. Okay. Yeah. That's it for today. Thanks for joining. Great stream. And Wednesday, next stream, same time, 10:30 p.m. Central European Time, or 2:30 Pacific Standard Time. And then I'd say we're out. Now what I'm going to do now is I'm going to play some PlayStation, and then I'm going to go to bed. Yeah, okay, Nick, we're doing Twitter. I'm also interested in Twitter. I think Twitter we can do two streams or three streams, because they have so much information and so crazy setups for the whole infrastructure and for the whole data processing and so on, and how they evolved over the time. So I think Twitter is Twitter can be super interesting. Okay, guys, great having you. We'll hopefully see each other back on Wednesday, and then have a great day, and see you then. If something comes up, you can reach me on LinkedIn or on Twitter. I'm more on LinkedIn right now. Okay, bye bye.